Venus, often called Earth's evil twin, has long fascinated scientists and dreamers alike. With its similar size and proximity to our planet, it was once believed that Venus might have had conditions favorable to life, possibly even oceans of liquid water. But today, Venus is a hellscape, scorching temperatures, clouds of sulfuric acid, and an atmosphere so thick it crushes spacecraft within minutes. Could this fiery planet ever have been a cradle for life? New research suggests the answer might disappoint us. By studying the chemical composition of Venus' atmosphere, scientists are uncovering clues that challenge the idea of a once habitable Venus, revealing a world that may have always been dry, barren, and impossibly hostile. As we uncover these secrets, we're not only learning about Venus but also refining our search for life beyond Earth. If this kind of exploration captivates you, make sure to like this video, subscribe to our channel, and join us as we uncover the mysteries of the universe. Venus has always been a planet of extremes. With temperatures reaching a blistering 1,000 degrees Fahrenheit, 500 degrees Celsius, and an atmosphere dominated by carbon dioxide, it's easy to see why it's often described as a hellish world. But what makes Venus particularly intriguing is how similar it is to Earth in terms of size, mass, and distance from the Sun. These similarities once led scientists to believe that Venus might have been a temperate twin to Earth, perhaps even with oceans of water that could have supported life billions of years ago. However, the harsh realities of Venus today tell a very different story. Its surface is a volcanic wasteland, covered with lava flows and crushed under an atmosphere 90 times thicker than Earth's. The planet's clouds, dense with sulfuric acid, block most sunlight, creating a runaway greenhouse effect that has turned it into the hottest planet in our solar system. Despite these conditions, the question persisted: was Venus always this way? Or did it evolve from a more Earth-like past? To answer this, researchers have taken a deeper look into Venus' atmosphere and geological history. A recent study conducted by a team from the University of Cambridge has challenged the long-standing theory that Venus might once have had oceans. Instead of relying on climate models, the scientists examined the current chemical composition of Venus' atmosphere, focusing on gases released by volcanic activity. What they found was striking: the volcanic emissions on Venus are almost entirely dry, with less than 6% water vapor. This stark contrast to Earth's water-rich volcanic eruptions suggests that Venus' interior has always been too dry to support the vast amounts of water required for oceans. This discovery has profound implications. If Venus was born hot, as this research suggests, it never had the conditions necessary to support liquid water, a critical ingredient for life as we know it. This finding not only reshapes our understanding of Venus but also narrows the criteria for identifying potentially habitable exoplanets. If a planet like Venus, so close in size and location to Earth, could not sustain water, it raises questions about the rarity of truly Earth-like worlds in the universe. But the story of Venus isn't just one of disappointment. It's a story of how planets evolve under extreme conditions and how those conditions shape their destiny. The more we learn about Venus, the better equipped we are to understand the factors that make a planet habitable or not. This knowledge doesn't just help us look outward, it also forces us to reflect on Earth's own fragility and the delicate balance that sustains life here. Could Venus hold even more secrets about the origins of planetary habitability? To uncover them, we must dive deeper into its past. Stay tuned, because the mysteries of Venus are far from solved. There are two competing theories about Venus's past, each offering a dramatically different narrative for how this scorching planet came to be. One theory suggests that Venus was once cool enough to host liquid water, potentially creating conditions favorable for life. In this version of history, the planet's destiny shifted when a runaway greenhouse effect, likely triggered by intense volcanic activity, caused it to heat up uncontrollably. The result? Any water that might have existed boiled away, leaving behind the hostile world we see today. The alternative theory paints an even starker picture: Venus was never a paradise. Instead, it may have been born hot, its environment too extreme from the very beginning to ever sustain water in liquid form. This scenario suggests that the planet's formation and geological composition prevented it from ever cooling down enough for oceans to form. recent research leans heavily toward this second theory. By analyzing the chemical processes in Venus's atmosphere, scientists found that any water present would have been rapidly destroyed and could not have been replenished from the planet's dry interior. What does this mean for our understanding of Venus? If the born hot theory holds, it changes the way we think about habitability, not just for Venus, but for planets across the universe. It suggests that even if a planet shares Earth-like characteristics such as size and distance from its star, those similarities might not be enough to make it a true twin of Earth. This revelation also highlights the role of volcanic activity in shaping a planet's fate. On Earth, volcanic eruptions release vast amounts of water vapor, a testament to our planet's water-rich interior. Venus, in contrast, releases gases that are strikingly dry. This difference underscores just how critical a planet's internal composition is to determining its surface conditions and its potential for life. The story of Venus serves as a cautionary tale, reminding us that the path to habitability is not guaranteed, even for planets that appear similar to Earth. As we continue to explore Venus and study its evolution, we're not just unraveling its mysteries, we're also learning more about the fragile factors that make our own planet a haven for life. Could Earth's fate one day mirror Venus's fiery demise? These questions compel us to keep exploring and to keep protecting the delicate balance that sustains life here. The new understanding of Venus has significant implications for the search for life beyond Earth. For decades, scientists have looked to Venus as a potential analog for planets outside our solar system, especially those orbiting close to their stars. If Venus had once been habitable, it would have bolstered the idea that similar planets, so-called Venus-like exoplanets, could harbor life. But the recent findings suggest a sobering reality: planets that appear to share Earth-like characteristics might still be fundamentally inhospitable. One of the most striking insights from this research is how Venus challenges assumptions about what makes a planet habitable. For years, scientists focused on factors like size, mass, and distance from a star, assuming that planets in the habitable zone, where liquid water could theoretically exist, would be prime candidates for life. But Venus shows us that these criteria are not enough. A planet's interior composition, atmospheric chemistry, and geological activity are just as critical in determining its potential for life. This revelation also shifts the focus of exoplanet exploration. Instruments like the James Webb Space Telescope are already studying the atmospheres of distant planets, searching for chemical signatures that might indicate habitability. If Venus was never able to sustain water, it suggests that similar planets orbiting close to their stars may also be less likely to support life. This doesn't mean the search is futile, far from it. Instead, it helps astronomers refine their strategies, focusing on worlds that might have more favorable conditions for water retention and stability. Venus's story also serves as a warning about the delicate balance required for planetary habitability. Its runaway greenhouse effect, driven by volcanic activity and atmospheric feedback loops, is a stark reminder of how easily a planet's environment can spiral out of control. For Earth, it's a powerful incentive to understand and mitigate our own impact on the climate, ensuring that our planet remains a sanctuary for life. Yet, even as Venus reveals its uninhabitable nature, it remains a vital piece of the cosmic puzzle. By studying what went wrong on Venus, scientists can better understand the complex interplay of factors that create and sustain habitable worlds. This knowledge will guide not only our search for life in the universe but also our efforts to preserve the unique conditions that make life on Earth possible. As the mysteries of Venus deepen, they also sharpen our focus, urging us to look further and think more critically about the conditions that foster life, and the fragility of those conditions when left unchecked. The more we learn, the more questions arise, and Venus remains at the center of one of the most compelling mysteries in planetary science. The future of Venus exploration holds the promise of answers to questions that have puzzled scientists for decades. While current research leans toward the idea that Venus was never habitable, only direct exploration can confirm these theories. Fortunately, humanity is on the cusp of a new era in Venusian science, with upcoming missions poised to unravel the planet's mysteries and provide unprecedented insight into its history. Leading this charge is NASA's Da Vinci mission, set to launch in 2029. This ambitious project will deploy a probe designed to descend through Venus's dense atmosphere, collecting vital data about its composition, structure, and evolution. Although the probe is not expected to survive the harsh descent for long, it may capture invaluable information during its brief journey, including a fleeting glimpse of the planet's surface. These observations could help confirm whether Venus's conditions were ever conducive to liquid water and refine our understanding of its volcanic and atmospheric processes. Another mission, ESA's Envision, aims to map Venus's surface in extraordinary detail. Using radar and spectrometers, it will investigate signs of past volcanic activity, tectonic movements, and chemical interactions between the planet's surface and atmosphere. Together with Da Vinci, these missions represent a coordinated effort to uncover Venus's secrets, bringing us closer to understanding why this planet's destiny diverged so drastically from Earth's. These missions are not just about Venus, they have broader implications for planetary science and astrobiology. By studying a world that evolved under such extreme conditions, scientists gain a clearer picture of the diverse pathways planetary evolution can take. This knowledge is especially valuable for the search for exoplanets. If Venus's history reveals that certain planetary characteristics are inherently hostile to life, it will help astronomers narrow their search to worlds more likely to harbor the conditions needed for habitability. Venus also serves as a cautionary tale for Earth. The runaway greenhouse effect that turned Venus into a searing wasteland is a stark reminder of the importance of maintaining planetary balance. While Earth and Venus share many physical similarities, their environmental outcomes could not be more different, a divergence that underscores how fragile and unique Earth's life-sustaining conditions truly are. As these missions approach, the excitement among scientists is palpable. Venus may not hold the promise of life, but its study offers something equally valuable, the chance to understand the mechanisms that govern planetary systems. Through Venus, we are learning not just about the universe but about ourselves, our planet, and the intricate forces that make life possible. This knowledge will guide future exploration, shape our understanding of habitability, and inspire generations to come as we continue to look to the stars for answers. So, as we prepare to unveil the final secrets of Venus, let us remember that every discovery brings us closer to understanding the cosmos and our place within it. If you've enjoyed this journey through Venus's mysteries, don't forget to like this video, subscribe to our channel, and share your thoughts in the comments. Together, we'll keep exploring the universe's most compelling questions.